Every 6 months, new tools and approaches come to the market to solve and optimize the problem. I will give you all of the new insights and the trends that are changing. This is where the industry is moving. So if you upskill in this direction, the chances of you getting a job and getting a new opportunity will increase.
Hey guys, today we're looking into the data engineering trends of 2025 and what to master. This is an original video from Dashil Pamar. You can find the link to it in the description of this video, and let's get into it. All right.
Data engineering is growing rapidly. As per this AIM report, data engineering market is going to cross 100 billion by 2020.
Well, by 2028. Okay, I mean, it makes sense, right? Because people are doing more data science, people are doing more data analytics. There's a lot more data getting created all the time, so you need more engineering to actually make this data available and for analysis.
While this happens, this is the best time to learn data engineering so that it can open multiple doors for the opportunities. Every 6 months, new tools and approaches come to the market to solve and optimize the problem. It is challenging to keep track of all of these new changes that are happening in the market.
That's true for me as well. And that is one of the big things where people struggle. They think they need to learn everything. They think they need to be up to date with everything all the time. So trying to focus on a few things, and let's see what Dashil brings up here for 2025. And basically try to keep a bit of an overview, but don't get necessarily into every one of these things.
In this video, I will give you all of the new insights and the trends that are changing. This is where the industry is moving. So if you upskill in this direction, the chances of you getting a job and getting a new opportunity will increase. Companies are looking for the people with all of this skill set, and there are very few people who have all of this. So this is the best time to learn it. So let's start with the video. Number 1 on the list is learning about DBT. Data build tool. Now there is a war going in the market to remove the old approaches with the new one so that we can optimize and improve the entire process. One of them is getting rid of the transformation layer. So in data engineering, we always do the ETL, extract, transform, load, where we extract data from the multiple sources. It can be RDBMS, APIs, web analytics. Then we do the transformation as per the final requirement from the data scientists, analysts, or business stakeholders. And
okay, I mean, completely replacing this, let's say, traditional approach of transforming the data before giving it to them. I don't see this as a completely replacement of this process. This is more something of a enhancement. This is something of a, we might need to do this, or we still want to keep some sort of simple ETL, simple transformations, and then do the rest in the warehouse, do the rest in our analytical store. But completely replacing it, for some reasons or for some use cases, this might make sense, but for others, you want to keep this. Especially when you think about data quality, you most likely want to first, when you extract data from the API, you want to run some data quality, maybe not transformations, but having some data quality things. So completely replacing everything that is basically transformation, that is coding before putting it in the warehouse, and then with DBT, then processing it there, then transforming it there. I don't see this as a complete replacement. This is more of a nice addition to the whole process.
When we load our data onto the target location, it can be data warehouse. Now this entire process requires extracting, transforming, or structuring data in such a way so that it can be loaded onto the data warehouse. Now the problem with this approach is that once your data is loaded, it is very difficult to modify or change anything. For example, a data scientist might be working with, let's say, 100 columns. He might require more 10 columns into the data warehouse because he wants to build a machine learning models or do some analysis. Now to achieve this outcome, we will have to modify the script, we will have to modify the schema on the data warehouse, load the data. It is not just about the loading. We will also have to backfill all of the previous data that are required to complete those different columns, right?
Okay, I mean, for this use case, absolutely. If you don't have all the data in the warehouse and you need to backfill it because somebody needs that information, that's annoying, right? But I mean, is this completely a replacement? of ETL, because ETL, as you said, modifying the schema, doing the transformations, doing quality checks beforehand, completely replacing this by just dropping all the raw data into your data warehouse. Not always, and I don't think that's a super good idea to do all the time. And very often, let's say backfilling, you can't actually replace this because or in many cases, there are new sources coming up, right? There are already data sources there, then somebody comes up with a different data source or finds a different data source and needs to enhance the data that is in the warehouse with that data source. So you are going to do backfilling anyways. Yeah.
So this entire approach is very difficult, complicated, and most of the data engineers spend a lot of time doing the entire thing. To solve this particular problem, we have something called as a ELT, extract, load, and transform, right? The steps are pretty simple but are in a different order. So this is the concept on which a DBT, a data build tool, is built on. It says that once you extract your data, instead of doing the transformation and then making the changes, then loading it, what you theoretically do is that load your data onto the data warehouse raw, right? And as per the requirement of a specific individual, right, data scientists, analysts, machine learning engineers, they will write their own transformation logic as per their requirement. They will pick their just 100 columns, 200 columns, whatever they need in any data type, they can do that and then build their actual model on top of it.
That doesn't fully make sense, I think, this explanation, because why would you then learn it as an engineer? Because with that, the analyst, the scientist, everybody would just do it on their own, right? They are going to use DBT. The engineer is not going to do anything in this case. In some cases, this might be true. In other cases, the thing is, think about what do you actually want to have the engineer do? What do you want to have the scientist, the analyst do? Right? The scientist and the analyst, you don't want to have them pre-transform the data in your data warehouse. Or for the analyst, take a few white tables and then create a dimensional model for that use case and then analyze that data. You want to have that prepared, right? So you don't just want to have the engineer drop the raw data in there and then, okay, be done. Because I think that is a bad thing. You want to have them prepare the data already for these use cases so the analysts can actually do their thing, the scientists can actually do their thing. And as well, like scientists taking data from a data warehouse and analyzing it, you usually most likely want to store this into some kind of a file format and put this into a data lake, because they're going to extract a lot of data and they're going to then take a lot of strain on the warehouse that you don't want. So it's more of an analyst oriented thing, and you want to have the engineers be able to support the analysts, and therefore DBT, because we can already prepare the data for them.
This saves a lot of time, that instead of you doing the transformation and making sure everything is right, you directly dump your data onto the data warehouse and then start doing the work. Again, this process is not straightforward. You will have to do a lot of configuration before and but this is where the industry is moving. They're trying to eliminate the transformation layer in between, directly load your data and then do the transformation as per the requirement. So learning DBT is very important right now. A lot of job opportunities are available. So if you can upskill in that direction, then it will help you a lot. Again, you can learn DBT for free online. You just have to search on YouTube and you will find plenty of resources. I'm also planning to create the free masterclass on my YouTube channel for the DBT. So if you're interested, you can just subscribe to my channel and stay updated for the future videos. Second,
I mean, free resources, there are a lot of free resources out there. I also have a course in my academy about DBT. In the academy, I did this with Snowflake in between, right? Or in conjunction with Snowflake, because this is such a strong combination. But I don't like this notion that people are going to try to eliminate completely the ETL process and just dump everything into the warehouse. It's also a cost thing, and I think you need to know both, and you need to be able to decide when to use which. That's one of the important things. Yeah. Look, I don't like these kind of black and white thinking of either this or that. It's on a use case basis.
Second thing on the list is open table format. It is very important. You must understand open table format. Why do they exist and what is the problem that they are trying to solve? We understood about the ETL in the previous point. This is where we extract, transform and load your data. This is a step-by-step approach to achieve the final outcome of the structured data. In this approach, we have a lot of complications, because anytime that you want to modify something or do something, you will have to go through the complicated process to achieve that outcome, right? Changing the schema, adding a column, removing a column, or anything like that, right? It happens a lot in the real world, so very common. Now to solve this, the concept of data lake came into the picture. It said that instead of building a plan, doing transformation and loading your data into the structured format into a data warehouse, why don't we just directly dump all of our data at one location, and as per our requirement we read all of this data and then do the analysis. It might
You see this kind of thinking, like the first one is really, is it called deterministic? Like you do the ETL, you prepare the data, and then you have it in a prepared state, and then somebody can work with it. Or the other case, you just take the data, you drop it in there, and somebody else is going to do the transformation and then is going to use it. The initial process of doing transformations is not going to go away. And yeah,
might be confusing if you are hearing it for the first time, but let's understand, right? In the business, we have the different users who want to understand and take the data-driven decisions. These are the people such as data scientists, data analysts, machine learning engineers, business stakeholders. Inside, let's say data scientists also, they might be working in a different teams. In the case of e-commerce, we have like shipping department, refund department, order department. There are multiple teams working on the individual problems. All of these different teams require their own set of data and data from the other teams also, right? Shipping department.
Yes, they all require their own data, and also the other team's data to some level. Yes, of course, you need to make sure that not everybody can see everything, right? That's
requires data about the orders, payments, and the shipping information, right? So all of these information they need to aggregate so that they can build the analysis dashboard or machine learning models on top of it. Now, when we do the ETL, it is very difficult to cater all of these different users because they require the different outcome at the end. So every time you want to modify something, you will have to raise the ticket to a data engineer. He will do all of the modification and then you will get the final result. Now,
yeah, it's super. This kind of process is super annoying, right? Do you see how this fits into ELT, and also how this fits into the whole data lake thought of, okay, let's put the raw data in there and have people access the data that they need? This all comes together because you don't want to have small changes and then you need to raise the ticket to the engineers, and every time the engineers need to do something.
To solve this concept, data lake came. Data lake said that, okay, instead of doing all of these things, directly load your data onto the centralized location like Amazon S3. So as per the requirement, you can start querying the data that you only want, alright, and get the final outcome. There are query engines like Amazon Athena or Presto that gives you the ability to directly query individual files, okay, that are stored onto the Amazon S3 using SQL, so that you don't really have to store all of this data onto the database like format, right?
Yeah, so that is, I think, Athena, AWS Redshift Spectrum, which is basically Athena just within Redshift. So if you have a data warehouse already, you can use this. Presto, these are really cool tool to query data directly from the data lake without needing to extract individual files and work with the files and use SQL. I think it's a cool use case. I'm excited if he's also coming to the data catalog topic here, because for using these kind of tools, you usually need to have a good data catalog so that you know or have this transformation of, okay, these are the files, this is the content of the files, and these are actually tables that you could extract from, or how you can use these files. Basically turning files into a table format and then using that to query data with SQL.
They are actually stored as a raw onto the Amazon S3 and you can directly query and work with the data. Now, problem with data lake is that it does not give you the flexibility to keep track of the changes that has been made. It does not give you the features like asset properties that are usually available onto the databases. To solve this particular problem, we have open table format like Apache Hudi, Iceberg, that gives you all of these features like databases, but you are still directly querying the individual files with some extra features. It is like a layer on top of it. Companies like Snowflake and Databricks have already integrated these open table formats because they understand this particular technologies is going to solve all of the major problems faced in the modern world. Number 3 on the list is real-time data streaming. We live in the world where we...
Okay, so take a look into that. I think that's a good tip. So it's a good tip. We're also thinking about something, putting that into the academy.
Want everything within seconds. I buy something online, I need the confirmation next second. You see, real-time streaming is everywhere. Companies are trying to integrate all of these different technologies into their system so that they can take the decisions faster and improve their overall business process. For example, when you go to the e-commerce platform like Amazon, when you buy something, you need the information about like your confirmation of order, shipping your order, everything that is happening, you need the notification. Same way, let's see, if you purchase my course, right? You need the confirmation within second about that your purchase was successful and the course is added in your account, right? So that you have the peace of mind that everything went successfully. As the volume of data and the speed at which a data is getting generated.
But that, I think that is a, yes, but it's not a really good example because that's not streaming. That is just a transactional thing that is happening within the system, right? It's not real-time streaming or some process. This is basically really a step function. You purchase, you get the email, you get subscribed. So it's not, data streaming is a bit different.
It is growing. We need people who can handle all of these data. That is the reason companies will be looking for the people who have all of these skill set. So learning tools like Apache Kafka or Fling is a good starting point. Every company will eventually...
Yes, Kafka. Yes, I still think Kafka is the basis for every message queue. It doesn't really matter if you're using AWS Kinesis or if you're on Azure with Event Hub or other tools, PubSub on GCP. They all work the same as Kafka, so it makes sense to learn Kafka. Flink, I'm still not the Flink guy. Maybe Flink is something to add into our academy. I think, especially for people who code with Java, Flink is really good. Otherwise, for me, I'm always a Spark guy. So for streaming, Spark is really, really nice. But I understand Flink is a big alternative that people use.
Require the people who have all of these skill sets. So it is the best time to upskill yourself, because when they do open the opportunities for these people, you are the person who already have these skills and you can grab that opportunity. I'm working on my Apache Kafka. If you're interested into learning more about it, you can check the link in the description. I will put all of the information there. Next on the list is data orchestration and workflow management. Now,
one sec, huh?
All of the information there. Next on the list.
That was open table form? How does that? I thought this was a different point.
Is data orchestration and workflow management. Now there are so many new companies are trying to enter into this particular segment of the business to solve this particular issue, and fundamentally it is right, because data engineering at the core is all about moving data from one location to some different location. There are some transformation required in between, and these transformations are divided into the multiple steps also. What these modern companies like Mage.ai, Prefect, Daxters are trying to say that instead of you writing a lot of scripts and managing it, what you do is that you just directly, I will provide you the connectors to the different locations, so you can just click some buttons, connect to the source, connect to the destination, and do some logic in between using some good UI interface. In order to build a data pipeline, we have multiple ways. One way...
Yeah, I think that is something that is coming really, really strongly right now. People are doing this all the time. I used Mage before. I also have a YouTube video on Mage and talked to the founder of Mage. These kind of tools are super cool because you can very easily integrate it or create complete pipelines within these tools. But also topics like Airflow are still super important because they allow you to easily orchestrate your pipelines, easily orchestrate your transformation processes. and also monitor them. So I think this is something that earlier on, a few years ago, was really annoying, and nowadays it's not that difficult anymore. And also like companies like Airbyte that make especially connectors for all kinds of sources where you can say, okay, I'm taking the data from here and dropping the data there. That is something really, really powerful to look into and to use.
You can directly write the script.
By the way, I have about Airbyte, I have videos in my YouTube channel as well.
Which is basically you have to use Apache Spark or Python, set up the entire infrastructure, okay, and then build your data pipeline. Second is using the SaaS tools like Mesh.ai, Prefect, that gives you the flexibility of not worrying about the backend infrastructure or anything, the code level. You just focus on the good UI, do the connection, do your transformation, and you're good to go. And the third approach is that using the open source tools like Apache Airflow, which is like the combination.
The thing is always, for me, I'm always the infrastructure guy, right? This needs to run somehow, somewhere. This needs to be scalable. And you could say, okay, with Mage, just focus on the UI and just create the connectors. But not every company is allowing you to use this in the cloud, right? As a software as a service tool. Very often you need to run this within the company because the data that you have cannot go outside, or you have some kind of a cloud environment where you need to install something. And then you need to have different solutions like Airflow that you can actually implement or install, run yourself. Of course, AWS has a managed Airflow service, so it's not a big deal.
Of scripting and also the workflow management, right? So you get everything at one place. The reason to use Apache Airflow is that you can customize a lot of things as per your requirement. You have the flexibility and it has a lot of features. So as per your requirement, whatever the problem that you are trying to face, you can easily fix it on Apache Airflow. If you want to learn Apache Airflow, you can learn it for free. I do have a course on it that can help you to get started from the basics to advanced. So you will learn everything about Apache Airflow from start to end. Next is integration of LLM into data product. Now this, we all know that companies are trying to integrate the AI into their existing tool set so that if you're working in the tool, it is much more easier and it can improve your productivity. A lot of people see this as a fear that AI is going to take their job, but instead of looking from that point of view, you can start.
Well, for us engineers, not some jobs, yes, AI is going to make it difficult for you.
Understanding how these tools can help you to do your job faster and it can optimize your entire workflow. So understanding how to write a good prompts and how you can integrate all of these new AI tools into your own workflow can help you to do your work faster and improve your overall productivity. So having ability to understand how to use these AI tools specifically tailored for that particular product will give you the upper edge every time you try to work in that.
Okay, Tershil, which are the tools? I want to know the tools. Like, are there tools out there right now?
That particular segment. Again, when you talk about all of these AI tools, people think that, okay, I don't have to learn anything else. I just have to learn tools and I'm good to go. Be completely wrong. You still have to clear your basic fundamentals because each and everything that comes into the market is just a wrapper on top of one approach and another approach, right? So if your fundamentals are clear, then you can learn any tool. If you learn any tool and if your fundamentals are not clear, it will be very difficult for you to adapt. So I highly encourage you to clear your basic fundamentals. I have the free 3 hours video available on Fundamentals of Data Engineering Masterclass. If you're interested, you can check it on my YouTube channel. It has more than 100k views within a month. So definitely check it out. It will help you to gain new insights on data engineering. Now, these were the main things, but there are some other things.
What? What about the AI tools? I don't get it. Like, let's quickly think about this. The AI tools. Which AI tools are there that you should use, or should be able to use? I think there are 2 things that you really need to look into as an engineer. Number 1, ChatGPT, because ChatGPT is helping us so much. It's crazy. Whenever you have a question, whenever you have problems, ChatGPT has some kind of solution or can help you along. First thing. Second thing is more in the engineering department, thinking about how to build systems. One of the big systems that you need to look into is retrieval augmented generation, RAG. So you have files, you have inputs. These inputs get indexed into some sort of store, and then you're basically asking questions, and the LLM, and it's retrieving data from the store, and it's giving you insight into files that are laying inside the store, right? Information about that. So I think that is something really, really important. A good prompt engineering for ChatGPT, and you need to figure out really how to use RAG. There's an example. I have that in my cookbook on GitHub. I'm also going to link this below. I just put this in, I think last week, a example of RAG example with Elasticsearch. I think this is a good way of working with AI as an engineer.
That I want to just quickly go through it. One of them is data governance and compliance. Tools like Calibra, Apache, Atlas help you to manage your data. For example, you have like thousands of tables available in your company. Each of these 1,000 tables will have more than like 100 columns available. So who owns this table? What is the meaning of each and every single column in all of these tables? What does this table mean? These kind of information.
That's a big thing. I think governance and like working with a good data catalog and then having good governance, this is something that we are facing and we're going to face more, especially when you think back with ELT and so on, and the open table format and data lakes. The more raw data you drop somewhere, the more difficult is it to find out, okay, what's the lineage, who's actually responsible for it, where does it come from, how does it look? It's getting, this kind of things are getting more difficult.
We need to keep,
and we need to have a good solution for the governance
at some location. So if you're trying to find a specific column or specific work that you have to do, you can easily go and find it. Or let's say if a new person joins in your company, right? He has no understanding about anything. So they can go and find all of this information at one place. Again, there's a compliance, which is basically masking your data, right? So you can't store the credit card information or the address information. So you have to mask your data as per the compliance. So this is one of the things that you can just learn about the theoretical side of it so that you will get the better understanding. Another thing is learning about the infrastructure as a code. Tools like Terraform and Ansible can help you in this. Like when we build our data,
we're actually right now creating a Terraform course. I already recorded the first few videos for it. Infrastructure as code is important. You don't want to click around in the UIs. And the cool thing with infrastructure as code with something like Terraform is that whenever you make changes, you can immediately then deploy them and have a good CI/CD path, right? That you first you make the changes, you test the changes, then you bring the changes to the cloud, and then you basically do a switch and from the old version to the new version, and immediately run this updated version on the cloud.
Data pipeline or data system, we have to configure a lot of things, right? Apache Kafka, Apache Spark, we will do AWS Lambda, we will do the glue, like a lot of things we will have to bring it together. Now, the best way to manage all of these is by doing the infrastructure as a code. So if you want to like set up the entire thing, you can just run the one script, all right? If you want to destroy it, you can just run the simple command and it will destroy everything. So it becomes much more easier to manage it rather than you going to the console level, clicking some buttons and trying to, you know, make the entire thing. This will, it is possible to do it, but managing that will get difficult and complicated to learn.
And annoying, you don't want to do this. I think this and Docker, these are the two very important things that came out that make life easier for engineers. With Docker now you can create some script, you can create a process, and you can deploy it everywhere without having to worry about the environment, the system that it's running on. There are all the dependencies are packaged within your container, so it's going to just run, or are packaged within your image, and then once it's initialized as a container, then it's going to run. That's one of the things. And the other things is infrastructure as code, and to basically make everything super easy to create, super easy to destroy, and manageable. I think that's why I think Docker and Terraform, or stuff like Terraform, these are super, super important.
Learning infrastructure as a code will give you the more flexibility to manage your entire data environment. So again, you don't have to really master it, just get a good understanding how to do it, just watch some tutorials and you'll get the good insights on it, right? So this was everything about this video. If I missed something, then do let me know in the comment section so that other people can learn about it. If you watched this video from start to end, then write the comment below, I watched the complete video. That way I'll know that you are up to date with the recent trends and where the industry is moving.
Nice way of
If you're interested in
getting
kickstarting your career
comments.
in data engineering, then I have the courses available. Check the link in the description. These are the courses that can help you go from zero to industry level data engineer. So you will learn everything. Again, only 5 courses available right now. I'm working on the more courses. What I'm trying to do is that build the in-depth courses individually so that you get understanding about everything. This was all from this video. If you have some suggestions, do let me know. Thank you for watching. I'll see you in the next video.
Good video. I think the way with the AI, using AI tools, that was really short. Would have loved to see more, but yeah, cool video. I'm already subscribed. Hit the like button. Let me know what you think. What are things that you want to see or you have to learn in 2025? Or also, what was it that you learned in 2024 that actually changed everything? Let me know in the comments, and then see you in the next video.